so this brings us to why we would use our projects. So I have my Class 2 demo on the desktop. I opened it up. I'm not in a project, as you can see here at the top. And what I'm going to do now is I am going to try to render this file. And what that does is just put it into that HTML document that we were talking about. And if I tell it to render, it is not rendering. It's running, but not doing anything. And here we go, it gets stuck. So it says error when opening file, no such file is or directory. And what that means is that it cannot open this ed data file because the ed data file is not on the desktop. And so it needs all of those files in the same place in order to build your HTML that is part of this. So instead, what we do is, in order to keep everything in the same place and make sure that our files know where they are, we use our projects. So that is one reason to use our projects. Another reason is because it allows us to use what is called relative file pathing, that is relative to the root directory of that project, rather than using absolute file pathing, in which case the file paths end up being really long and then they vary if you're sharing a project with somebody else. Their absolute path is not going to be the same as your absolute path, so we want to use relative file pathing, and the way to do that is via our projects. So I'm going to see if I can show you an example of the relative versus absolute file pathing and why we want to be using relative. It becomes even more of a big deal when you're doing collaborative projects with other people. But say I wanted to find this ed data file. So I'm going to try and find it in my Okay, so I have the absolute file path here, and this is one workaround and one option for you to render is, instead of using the relative file path, since I know exactly where this is, I'm going to point to exactly where this is, and then when I render it, it will be able to go ahead and render it because it is pointing to exactly where it is. So even if I move the demo to the desktop, it can still render the document, right? The problem with that is that once you start working with other people, these paths, right, other people might have their data in different places, and they're going to have to change their file paths or the first part of that file path. And one way to get around this is to do something called our projects, which eliminates the need for a lot of that front end stuff in the file path, and it also allows it to play well across different people. So I would be able to use the exact same code as someone else if I'm also using the same root directory that they have. So we're going to standardize and normalize that root directory. I hope that makes sense. If it doesn't, that is normal. We can talk about it a little bit more in class. So we are going to get rid of this and go ahead and use an R project. So So I have already set up an R project. I'm going to show you how to set one up. It's very, very, very straightforward, another point and click situation here. But I have set up an R project in our course folder, so we're gonna dig into that. And here we are. And you can see that in my directory, it says lecture materials.rproj. So so this is the root directory of all of the things that I'm going to use for a lecture. So I'm going to go ahead and open that project. And this is something that if you are working in a project, always remember to actually open the project file. A lot of times I will open my Quarto document or our Markdown document, but not actually open the project, and then I will have to reopen that file that I want in the project. So always start with opening or initiating your R project. And then you can see that within that lecture 1.2, I have some data that I want to use. So we are going to, I'm going to go ahead and move this class 2 demo into my lecture materials R project, and I'm going to go ahead and move it down into lecture 1.2. So I will open class 2 demo here, and now again I'm opening it in the lecture materials R project, and I'll tell you why that's important soon. Okay, so I have my Quarto document, and we are going to change our data that we're going to use here. We are going to use this Taylor Swift Spotify data. And because it's an Excel file, I'm going to go to source mode because that's what I like, and I am going to read it in as an Excel file, or from an Excel file. And then the name of the data that I want is Taylor Swift Spotify data. Okay. But now if I push this, it is not going to run. It will tell me that I'm in the wrong place. So I will do that and I'll show you. It says path does not exist. The reason for that is because my working directory, the place where this is starting, is from the lecture materials folder. And the Taylor Swift Spotify data is within another folder, lecture 1.2, underneath that folder. So if I want to load that data, I'm going to have to start with file pathing lecture 1.2. Okay, so now I will be able to read in the Taylor Swift data. And you can see here, it reads it in and it tells me, okay, here are the playlist IDs, the album, the song names, and then I have some columns for danceability, energy, loudness, all that stuff. Okay, so I have some data. I have my class 2 demo start, and this is my Quarto demonstration. So I'm going to write down here the next thing is going to be a second level heading, which is read in Taylor Swift data. And then the below lines of code will read in the Taylor Swift data. So let's see what this looks like now if we render it. And while that's rendering, I just want to point to one thing, which is that now, if all right, we are not. All right, just learned something new, which is I think that you have to have your Quarto document that you're knitting in the exact same place as the root of your project. So you cannot have it in a subdirectory of your project. So that is good to know. Might help save us some errors down the road. So if you are using a project and you are wanting to knit a document, have that document in the root of the project directory. So now I'm gonna try and render again, see what happens. So the good news is that if I gave this exact folder or file or set of folders to someone else, they should still be able to knit this exactly the same without changing that file path. So as long as they have the same things in their folder, the same art project, the same everything, they should be able to knit the exact same thing on their computer, don't have to change a thing. So that's where we talk about this relative file pathing really coming in handy when you're doing collaborative stuff and you're working with other people, so that you're not having to worry about file paths changing, and they're always in the exact same spot across different computers. We'll talk about Git next lecture and how we keep everything in the exact same file path. It's a little bit like working on a shared drive, but a really obnoxious shared drive that really wants you to like have everything perfect all the time. And that's the best way I'll explain it, and we'll talk about it in more depth throughout the class. So yeah, this is what it looks like. And the cool thing is we get this little viewer that tells us, okay, this is what our document looks like. So it gives us the first 10 rows of the Taylor Swift data. And it says this is the Quarto demonstration. Read it, and the first thing it says is read in the Taylor Swift data. Okay, you'll notice I also have, since I have the title, it does this twice, so I don't actually need that first little heading. I can go ahead and take that off, and we can start right into there. Okay, so I'm going to save that. We've read in the Taylor Swift data, and now I'm going to check what else we're going to do. We're going to talk about our environments. Okay, so we've already practiced rendering a little bit. I'll give you some more tips on that, but we're going to talk about our environment next. So when you are starting a new project, it is one thing that can help us is using this package called our environment, or our Renv, R-E-N-V, and that package helps to make sure that all of your packages and versions and everything else live kind of inside of your project, so that if someone in a year or 2 years tries to run this, that they'll have all the same versions of all the same packages that you're using, and that they all kind of can live and be updated within the project. So let's see, then the first thing that we'll do is at the very top of this, I am going to, you know what, I'm not going to do it in this. And do something called init. So this discovers like all the things in the project that the different libraries that we use in the project, things that are dependent. So for instance, read Excel, right? That might be in there. And then we're going to look at that. And then it includes all of these into what's called a lock file. And these are the package versions that it is using. Go through here, the packages that are clicked. A lot of these are the kind of the base packages that are here with most new projects. Okay. So if we want to, if we change something, so say, so you can see read Excel is not in here. Oh, it is, it's in here. You can see that there. Let's pull a new, package in and then do a snapshot, which will update our lock file. So a new package that we might want to use, let's try, looks like we do not have dplyr on here. So we'll use that. So put that here. And you'll notice it says there's no package called dplyr. And that is because even though I have it in my general R, we have not installed it into this project yet. So I will have to install dplyr into this project. And it says we're going to update that package. And then can I load it? Yes, now I can load dplyr. Now, if I don't save dplyr here into my, you can see it's still not listed in my R environment, right? So I am going to do a snapshot. All right, and now we can see that dplyr is updated here. So what I am going to do now, so this is here. I'm going to take a snapshot of my library. And then it says that these packages are going to be updated in the lock file. So now I'm going to have all of these packages in the lock file. And you can notice that, like, even though I just I just updated or installed dplyr, all of these other packages were also changed, and that's because dplyr runs off of some of these other packages, and so it includes them. So it is going to change a lot of these packages. That's totally okay. And this is why we want to take these snapshots. This is why we want to keep everything up to date, so that if someone wanted to use this project, they can use the exact same packages and versions that, that I'm using on my computer. So we're going to go ahead and take that snapshot. You can also do it in the command line or in the console via snapshot. All right, cool. So now we have dplyr that is also here. Great. So I'm going to save that. And that our Renv script we don't need to really have that anymore. But it's there if we need it. Okay, so hopefully that was a quick little introduction to the R environment and why we'd want to use it. It's to make sure that the packages that I have loaded are the same ones that if anyone else is using this project, that they have loaded as well. So if I'm giving them a zip file with all of this on their, that they can use, or I'm uploading it to GitHub and we're working on it collaboratively, that everyone is in the same place. Okay, so we have done a lot now. We've gone through file pathing, some basic writing with Corto, using our projects. We've done some rendering. Let's just do a little bit more to round it out. So let's take our Taylor Swift data and do something with it. Okay, so I'm going to pull this back into my environment here, and I'm going to name it TS data. So now I have this TS data, has 147 observations of 16 variables, and you can see those are all just the Taylor Swift songs that it has. So what if I wanted to pick out all the songs that have a danceability of greater than 0.5? Let's say that. So what are her most danceable songs? Let's do it. So the next thing is I'm going to put another second level heading, and I'll say most danceable that just doesn't seem right. Okay. Yeah, that is right. All right. And in order to do that, I'm going to use my dplyr, and I'm just going to filter these. So I'm going to say, I'm going to create another data set that hopefully will be pared down with just the most danceable, and I'm going to say it's going to be TS data, and I'm going to filter danceability greater than 0.5, and let's just see how many we get. We got 123, so that's too many. Let's try 0.6. 78. Man, I think we can go, let's just try to get, okay, now we're getting there. All right, these are the top 5. So let's say these are the top 5 danceable TS songs. All right. Think about what your guesses are as to what they are. Haven't looked at them yet. Blank space, maybe. That's got to be on there. Yeah. It's got to be a lot of 1989, I feel. We'll see. I think 1989 is going to be overrepresented. Lover, okay, clean is not, I disagree. Okay. So these are the most or the least danceable. I'm skeptical of this danceability rating. I would like to know the features of this. All right. Well, here you have it. The most danceable Taylor Swift songs according to Spotify. And let's see if maybe we just want to put those album, song name, and danceability ratings there. So let's just select those. All right. There we go. So this is our table of most danceable Taylor Swift songs. So if I render this now, think about what you think it might look like, and then we'll look at it. So I'm going to go ahead and render. All right, here we go. So you can see that we've got our heading. It's loads dplyr. Notice that we have a bunch of stuff here that maybe I don't actually want this like loading dplyr and results here. And then it says the below lines of code, read in the Taylor Swift data. And then these are the top 5 danceable songs. And you know what? I am just gonna be extra fancy and put that into something that looks a little nicer. I called it cable. So I'm gonna clean up how it's rendering here to just make it a little cleaner, a little nicer when I render. And how do I do that? So within the R code, I can do a couple of things. So these are the kind of chunk options. I am going to choose echo for this one, echo equals false, and then message, because that's what the attaching dplyr, all that stuff. I'm going to put that as false too. And then we do want this this code here, and then this code. Let's actually just not show the code here and just show the table. And again, I'm gonna be extra here. Knitter cable most dance. We don't have knitter loaded, I don't think. Let's look at our environment, our packages. Do we have knitter? Yes, we do have knitter. Okay, good news. We don't have to update our environment. So yeah, let's and then we're gonna do the echo equals false here as well, but there's no messages, and we do want the results to come out, so we will use that. So we'll just use echo equals false. Let's also demo. I'm gonna name this how to Corto. Okay, So rendering again, see if it looks any different. Yeah. So now this is what the render looks like. I'm gonna make it just a little bit bigger. Yeah, so you can just see that. So this is it. It says here's the Class 2 Quarto demonstration. We read in the Taylor Swift data, and then these are the top 5 most danceable songs. That's it. That's the thing. So hopefully you learned a little bit here about how to use Quarto, what it looks like, and how to start thinking about using and writing in our Markdown. We'll talk more in class. If you want to look at how this looks in visual mode, this is how it looks. So it's like somewhere in between, essentially, the knitter and the source. So it's a little more readable than the source code, but not quite at you still have to knit in order to see what it looks like. So I'm gonna save that, and then we're gonna go back to the folder, and I'll just show you here. Now I have this HTML, so this is actually what knit, and it's its own file now. So I now have this output that gives me that file. So this is an example of what you'll be doing for